Hello everyone. Today I wanted to show you a game I wrote for ASCII basic game 10-liner competition in 2021. It's called Mathsticks. Mathsticks, it's a puzzle game. It's called actually Mathsticks 10 because it's a 10-liner. And this game is some kind of idea which I found in the past on the matchboxes, where you have a puzzle to solve an equation. So this is 10 lines of this awesome code. I'm going to explain later on. So I'm going to run the game first in this video, and then I will show you a few tricks I did, and I will share some challenges during this project. So feel free to check it out. Alright, so let's run the game first, so then you can see how it works. So first of all, it generates the set of matches. So the first number is actually 7, it's not 1, if you're asking. And then the thing is that one of the matches is in the wrong place. So only by fixing the match and moving it to the different location, we should be able to solve the equation. Left side should be equal to the right side. So 7 plus something which doesn't exist, this is not a number, is equal to 13. So what we can do, if you would move this stick here, then it would be 1 plus 8, which is 9, which is actually, of course, this is incorrect. But what we can do, I guess, is just, I think that 7 plus 5 is 13. So if we would need to move this much, no, actually, this is not the case. Sometimes this game is actually tricky also for me. I'm still having some nice challenges from time to time, which I like. Okay, so let me think. This is easy, probably. Okay, I see it right already. So I think that was 7 plus 6 actually is 13, not 7 plus 5, of course, obviously. So in this case, this much should go up. So the game is actually written in BASIC, and I haven't had that much of space to do some way of moving this much with UI. So you have just to type the answer. So the A is the first number, then B is the second one. We said it was 6. And yeah, the answer should be 13. And if it's correct, then we are following to the next challenge. Otherwise, the game will stop. And you have seen already that there was some equation in the making, but it was skipped. I'm going to explain later on. In this case, for example, it should be, I guess I should move this stick here, and then 1 plus 2 is 3. 1, 2, and 3. And that's correct. Okay, and in this case, interesting. Actually, it's really interesting. Okay, 4. I think 4 needs to stay. That's my best guess. Oh yeah, 1 plus 3 is 4. 1 plus. So this stick will be moved. This matchstick will be moved here. Yeah, that's correct. I think that you are not able to move the signs. Only the digits can be moved. 6 plus 8 is 14. This is actually correct. I don't know if I can I actually leave it like this? Yeah, that was actually correct. Probably the game tried to force me to move one stick still, but the algorithm I wrote actually also takes this option into account. I'm going to talk about later. Okay, and then the last one, it's already, this one goes here. 1 plus 4 is 5. Okay, so now I will just try to break it by answering incorrectly. Okay, that was not a good go. 1 plus 5 is 6, but let's say that 1 plus 3 is 6. Okay, this was incorrect, and then I got the answer, the correct answer. So I got 5 points, and then the extra thing I added is that you are also having the total time. So you can try to go for a record. Okay, so let's move to the code, and I'm going to show you a few challenges I did there. Okay, so this is code. Let's try to stop. Maybe I will go from 0 to 8. Can I fit on the screen? Not really. 7 should be fine. Okay, so I'll show you first 8 lines, counting from 0, of course. Why counting from 0? Because 0 also takes one less character, of course. So the challenge was that the line can only have 72 characters, and I used abbreviations. So you don't see these abbreviations here because Basic expands that, but the abbreviation would look like this. Read, I changed it to the lowercase because then you can easily see. For div, actually I don't remember this one. Is it DE or DF? Let's keep it def because I don't remember. For int, I think it was in, but yeah, a few things I forgot, but haven't done this challenge for half a year, so my memory already went down. So in this case, you would have something like that. And data is like this, and then 60, 10, and then that would be the line. But of course, if you expand it, it will take more than 72 characters per line. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 8. So 2 lines, it's 18 characters. So I fit in with this line with 72 characters. So that made this challenge harder. And so not only 10 lines, but also the 72 characters per line limit. And because of that, I played with different ideas, and in the end, I created 4 versions, including a different approach of locating matches on the screen. I used numbers randomization and answer validation. So there are different versions I did, but this is the final one you see on the screen. So this involved a lot of commands, swapping to squeeze them in a single line and finding some patterns after writing a portion of code and to making things clever. Or just shorter, as I still think there is a way to make this code more clever. There must be, right? So it was some sort of question about the infinity of possible solutions against the finite amount of lines available. So the simplest trick I used was to spread variable initialization by using read and data. So you can see a few examples here and there. Like there's data over here. There are just scratches of data. So this was like an iterative process. I needed to move things to different lines and see if it fits. So it was a lot of swapping and saving of the character space, like the one with the most common numbers occurring in the game. So the data is spread in different places, and then you can see that I'm actually like data is also here in this part of the screen. It actually tries to this is like a string which is then used to draw some stuff, and then here is a match itself. You see, like going down, then going left, drawing an vertical line, and then repeating another line the next row, and another line the next row, and then yeah, there are some tricks I used just to try to fit the match representation. So I also used a trick with like assigning, for example, number 10 to the Z. You can see read actually is here. Maybe I will try to make this 0 again. Yeah. So if I read the Z value, this is the second one. I actually used this Z more than once, so I had no space to put 10, so I just loaded as 10, and then I was able to reuse it in a few other places. So that's one of the tricks I used. I also defined a function for randomization, which saved just a few characters. But yeah, a few I needed. So this is the one and only function I used, and I use it in 2 places, I think. And then another idea to save some character space was to define the graphical representation of all matches, not within data, but with printing values as PETSI characters on the screen. So I used the same color as the background to print them, so they are not visible, but you can find them on the very top of the screen. I'll show you. Okay, let's break it. And you see they are here actually. So yeah, that's a trick I used. Maybe I should show you with changing the screen. Okay, so now you can see it. And this data over there, just by reading this instead of array, assigning an array, I use peak, and this data was just grabbed from the top of the screen. But of course you cannot see it while playing the game. You cannot see this portion of data on the screen, but this also saved me a few lines and characters. Of course, the other thing worth to mention is that the space available is really small, so code is not able to replace one match ahead before drawing all matches on the screen. So this is why it happens that during the rendering of the equation, a match taken from one place cannot be moved to another. In such situations, I added a fallback to reshuffle an equation, which will cause also a redraw of the screen. Not a big deal, but I really had no free space to write some sort of a dry run or provide some fixed possibilities. One of the earlier versions had a naive approach of accepting an answer as a correct one, only when the first and the second digit were exactly the same as the numbers randomized by the program. So what could happen in such cases, though, is that when the program randomized 2 plus 3, for example, which gives 5, and the player would provide 3 plus 2 is equal to 5, it would be treated as an incorrect answer. But yeah, this is of course a correct answer. It's just the different position of matches. So that was the first approach I did. And everyone knows that addition is commutative. So yeah, meaning that order does not matter. I should consider that when I wrote the first version of the code. So of course the program needed to behave the same way, but there was no free space left. 10 lines of code taken already, so that was really a struggle time for me. So this is like a easy game, but when you go into details, you can find that your design decisions are not really good sometimes, and you have to rewrite part of the functionality. In this case, it was really hard because the game was already done, and I only found it later on after dealing with all spaces and putting stuff in different lines and trying to squeeze and so on. So that was a little bit of a bad timing to for finding this out. So then moving a match with some pointer rather than providing values from the keyboard would be a perfect solution, because then program would only need to check and then if the shapes of all matches are referring to numbers, because then I could just see like, okay, this is an existing digit, this is an existing digit, and that would work perfectly. But of course, why I didn't do it is that I had no space left. So then I decided to use inputs instead, as it was just shortest, which is not perfect, but it works. It seemed that the project cannot be finished, but I knew there must be a way. And I found one actually by having a eureka moment during some random walk. What I realized was that to solve this problem, I have to think about the balance, kind of. When one match goes somewhere else, so for example, when this goes like 3, maybe, I don't know, actually, maybe this goes here. The balance is still there, so the program has to validate the player's input to see if the amount of matches is the same and the equation makes sense. Of course, under some circumstances, there is room for some other answers, but it's rare. So this way I saved a lot of space by reusing the same code which already renders matches on the screen to add another dimension to it, to not only render, but also count a number of matches provided from the player's equation. So then I was able to also see if these two variants make sense. And then this solution saved the project. I was able to see if there are still the number I provide is still valid because of the number of matches, and if the equation is also valid. And this also applies the commutative addition that 2 plus 7 is the same as 7 plus 2. In this case, it's 6 plus 7, I think. So of course you can provide 7 by plus 6, but it doesn't matter because this will still be valid in this case. And it is. Okay, so in the end I learned that when auto starting the game, you will get the exact same seed every time the game runs. So as the result of all equations were not random at all, but followed the same sequence each time the game ran. So that was really bullocks, and I needed to find a solution. So it was caused by no user interaction. Yeah, I decided to skip this. As for running on the real hardware, you would always spend different amount of time of loading the game and running the game. So that solved the issue. But yeah, that's something which I also didn't foresee. For making things really random, it was actually a little bit hard. So okay, that's all for now. I am going to show you also in other videos. You will see other games I did for basic 10-liner competitions, different competitions. This one was for not basic 10-liner competition, but for ASCII 10-liner competition. So a little bit different rules, because in the other example you can for the other competition, basic 10-liner competition, there's like a pure 80 competition, which means 80 characters with abbreviations are allowed. In this case it was only 72 characters, so it was a little bit harder, but still I managed to make this game. So I hope you enjoyed this video. Let me know in comments what you think about this game and about 10-liners in general. And if you see anything I could improve in this code, also I'm happy to hear. It's a little bit hard to read, but if you go to my website, commodore.itch.io, and check for this game, you can find some explanation line by line, which tells you more about the variables. And actually I have the description of variables also there, but just not put into a separate table or something like that, but they are just in the description of each line. So yeah, then the code is getting more easy to understand. Thanks for watching again, and see you in the next video.